Data analytics is the process of examining raw data to draw meaningful conclusions and insights. It involves applying systematic techniques to transform raw information into actionable knowledge that helps organizations make better decisions. Data analytics consists of four core components that work together in sequence. First, data collection gathers information from various sources. Then, data cleaning removes errors and inconsistencies. Next, data analysis applies statistical methods to find patterns. Finally, data visualization presents findings in clear, understandable formats. There are four main types of data analytics, each serving different purposes. Descriptive analytics tells us what happened in the past. Diagnostic analytics explains why something happened. Predictive analytics forecasts what might happen in the future. Prescriptive analytics recommends what actions to take. Each type of analytics builds upon the previous one to create a comprehensive understanding. Together, they form a powerful framework that transforms raw data into strategic business intelligence, enabling organizations to learn from the past, understand the present, and shape the future through data-driven decisions. The data analytics process follows a systematic approach to extract insights from data. This process consists of 5 key steps that work together to transform raw data into actionable business intelligence. Step 1 is defining the problem. This crucial first step involves clearly articulating what business question you want to answer or what problem you need to solve. Without a clear problem definition, your analysis may lack focus and direction. Step 2 involves identifying and locating relevant data sources. Data can come from internal systems like databases and CRM platforms, or external sources such as APIs, public data sets, and third-party providers. The key is finding data that directly relates to your problem. Step 3 is the ETL process: extract, transform, and load. This involves extracting data from various sources, transforming it into a consistent format by cleaning and standardizing it, and loading it into a data warehouse or analysis-ready format. Step 4 involves building analytical models. This includes applying statistical methods, machine learning algorithms, or business intelligence techniques to discover patterns, relationships, and insights within your data. The choice of model depends on your specific problem and data type. The final step is communicating your results effectively. This involves creating clear visualizations, writing comprehensive reports, and presenting findings to stakeholders in a way that drives decision-making and action. Now let's explore the essential tools used throughout the data analytics process. These tools are specifically designed to handle different aspects of data work, from querying databases to building machine learning models and creating visualizations. SQL, or Structured Query Language, is the standard language for querying and managing relational databases. It's essential for extracting specific data subsets, joining tables, and performing basic aggregations during the data extraction phase. Python and R are the two most popular programming languages for data science. Python excels in machine learning and general-purpose programming, while R specializes in statistical analysis and data visualization. Both offer extensive libraries for data manipulation and modeling. For data visualization and business intelligence, Tableau and Power BI are industry-leading platforms. These tools allow analysts to create interactive dashboards, generate automated reports, and present complex data insights in visually appealing and understandable formats. These tools work together throughout the analytics process. SQL extracts data from databases, Python or R performs the analysis and modeling, and Tableau or Power BI creates the final visualizations. This integrated approach ensures efficient data flow from raw information to actionable insights.